So guys, today's topic is Profit, which is a tool for time series forecasting, which was introduced by Facebook. It has a lot of interesting use cases. For example, you can use it to forecast your sales, and therefore, based on that forecast, adjust your inventory. You can forecast the number of servers that you need to operate when you are offering an online service. Or airlines, for example, could use it to forecast how many seats they need to offer during the next summer holiday period. And Profit is especially useful for business-related time series with clear seasonality, for example, weekly, monthly, or yearly seasonality. And there are a couple of main advantages that Profit offers over other time series forecasting tools. First of all, it's straightforward and easy to use, as you will see in the later examples. It's robust against missing data, and it is usually pretty good at dealing with outliers, even though obviously you should still clean your data before doing any kind of analysis. And as mentioned before, it is really good at detecting seasonality that is caused by human behavior. So for example, weekly or daily, for example, that the sales of a specific product are usually much higher on a Wednesday than on a Monday, just as an example. Moreover, the default settings of Profit usually deliver pretty good results, and you don't need to make a lot of fine-tuning, even though the fine-tuning that you can do is really straightforward and really easy. And what's also quite a nice feature is you can easily include irregular holidays in your forecast. So for example, if you're operating an online store, you can include in your forecasts events like Black Friday or the complete Cyber Week or something like that. So then a quick basic overview on how does Profit work. So it is based on an additive regression model with three main components. The first one is the trend component. You can either choose linear or logistic growth. You usually choose logistic growth if you have some kind of bound on the growth. For example, if you are dealing with market share data, you cannot get over 100%. So then you use logistic growth. And then secondly, we have a seasonal component, which is usually daily, weekly, and yearly. And lastly, we have the holiday component, which, like the name says, contains holidays or any kind of special events. So the forecast is based on the trend, the seasonal component, and the holiday component, and obviously an error term. So then let's get straight to the code. So it's really basic. So within 6, 7, or 8 lines of code, you can actually do your forecast. So first of all, important is to know that you always have to rename your columns as DS. So the column that contains the dates needs to be called DS, and the column that contains the data that you want to forecast needs to be called Y, otherwise you cannot call Profit. Then you initiate the model, just give it a name and call Profit. You fit it, basically with name.fit. Then it also has an inbuilt function to create the future dates that you want to do your forecast on. So also really straightforward. You implement the name, then .make future data frame, and then you specify the periods that you want to forecast, for example, 60 days. Then you basically make the prediction, name.predict, on the data frame that you just created, and then you can also plot and analyze the performance of the model. So obviously, first of all, we need to import all necessary packages after installing them before. Then we import the data set here. For this example, I took monthly data on US airline passengers from 1949 until 1960. As I said before, we have to adjust something on the columns. First, they need to be in a specific format. So Profit requires the date column to be in the datetime format. So we just transform it using the pandas function. And after that, we rename the columns to DS and Y, as mentioned before. This is required by Profit. And here we have a clean data set. Obviously, if you have some kind of tidy data, messy data, then you need to do some cleaning before. So then when you initialize the model, you can basically just give it a name and call Profit. Moreover, you can do a lot of tuning already here, so you can decide which kind of growth you want. If you have a bounded, so saturating data, as mentioned before, market share, for example, you need to specify that you want your growth to be logistic, otherwise it will use linear growth. Then you can add seasonality, but it's also included automatically. Moreover, you can change the number of change points. You can set specific dates as change points, but this is something that we can take a look later at more in detail. And this would be the syntax. If you want to change anything, you just put in the parameter that you want to change and assign the value. So pretty straightforward, as I said. After you initialize the model, you just fit it on the data. And here you already see that Profit is automatically seeing that we're taking monthly data, and therefore it automatically disables weekly and daily seasonality. Then, as mentioned at the beginning, we can use that inbuilt function make future data frame, which kind of just gives you the dates that you want to make your forecast based on. So I specified 72 periods, so it's giving us the following 72 months. So as you see, we will be at the end of November in 1966, and our data set ends in 1960. So this is 6 additional years, which are 6 years because we specified the periods to be 72. After that, we make our actual prediction. You just again give it a name, call your model.predict, and initiate and insert the data frame that we just created before, and then you get these kind of forecasts, which is a lot. Actually, you see a lot of different columns. So here you see the trend component. You have this y hat lower and y hat upper. You have trend lower, trend upper, and the most important column is the last one, which is your actual forecast, which is y hat. So this is the forecast that the model has come up with. And here we just take out the, for us, important columns of the dataset and take a closer look. So for example, our model for the end of November, so from November they forecasted there will be 675.99 million passengers. Then we can plot the prediction that we made, and in this plot you can see at the beginning these black dots. These are the actual data points. So this is the data that we inserted, and the dark blue line is the prediction of our model, and the shaded light blue shaded area is y hat upper and y hat lower. It's kind of give you kind of a confidence interval. You could see it like that, and you see right here there's no black dots anymore. So this is our actual forecast for the future, which we have no data for. And then you can call this function plot components. Here Profit gives you first a trend. So we see the overall trend is increasing over time. So there seem to be more passengers year after year. And secondly, we see a yearly component, which shows us that especially during summer holidays, July and August, we see more flights and more passengers. And for example, in November, there is really few passengers only compared to the summer. And if you would have daily data, we would also see such a graph for weekly and daily trends. And then I have a second example, since kind of a bit to catch your attention, since all this stuff about cryptocurrencies and Bitcoin is on the media all the time. I just thought it could be pretty interesting to just create a little forecast. Obviously, you shouldn't trade on that, or it's not precise at all, but it's just, I think, nice to see how quickly we can make a forecast with that tool. So here we import data from Yahoo Finance starting from the beginning of 2015, and yeah, take a quick look at the data. We see here, actually we're starting at the end of 2014, and the relevant column for us is the adjusted close. So we here we get us the date column and the adjusted close, because only those are relevant for us, and again rename them, otherwise we couldn't call Profit. So we initiate the model, we fit the model to the data, we create a future data frame, which is exactly the same as we did before. Here we specify the periods to be 365. So we are going to predict the price of Bitcoin for each day of the next 365 days. So basically 1 year into the future. So you see the future data frame will end at the 3rd of December in 2022. And then we forecast the price by just calling the predict function, and then we take a look at our predictions. Here we see again the trend, y-hat lower, y-hat upper, trend lower, and so on and so on. And here you already see that this time we also have weekly seasonality. And again, the important column is the last one, where we see our actual forecast. Again, we can plot this, and here we can see from 2015 onwards how the Bitcoin was doing in black. Blue line again our forecast, and here you can see over the last year the model had kind of difficulties to follow this, and you see our forecast is that the price will further increase going forward. And here again we call plot comments, which basically will give us the trend once again. And here we see that the price kind of skyrocketed after, March 2022 basically. Here we see a weekly trend, which is kind of interesting, that Bitcoin seems to be, at least in the past, has done better on Mondays, Fridays and Saturdays, and on Thursdays it seems to be doing pretty bad. Moreover, in the next plot we see on the yearly component, the yearly seasonality. It seems like Bitcoin is doing better at the beginning of the year than during the end of the year. Then we can also use the profit model to evaluate our model. Therefore we import cross-validation and just call it as a function. We insert our model and we insert the horizon that we want to validate our model on, and it will give you a kind of a data frame with our prediction and the actual value here. And then you can insert this cross-validation data frame into the next function that is already inbuilt in Profit, which is called performance metrics. Here you insert the data frame just created right here, and it gives you all the well-known measurements for error that you will use if you do any kind of forecasting or machine learning. You will always encounter these errors: mean squared error, mean absolute error, mean average percentage error, and so on. And you can also plot this visually, where the error term, where this is basically the error of your model. Obviously, as you see, really high errors, which was kind of expected, since we did it just more for fun, to catch your interest, and maybe you want to play a little bit around with it. This is 6 or 7 lines of code, and you will come up with a forecast already. And for example, if you want to do some stuff here, you can just change the ticker and get data on Microsoft, on Apple, or on the S&P 500, whatever you want, and play around a little bit. Then I want to talk a little bit in the last couple of minutes about suggestions if you want to tune your model. So as I said before, the default settings are usually really good, but if you want to fine-tune, there are 4 or 5 parameters which will have a big impact and which are suggested by Facebook. If you want to tune, then you should tune them. So the first one is the most important one, change point prior scale. What is, as I said, it's the most impactful parameter, and by default I think it is 0.1, if I'm correct. But however, you can change it, and the larger you make this value, the more flexible your model will be to follow trends. And the lower you make this value, the less flexible will your model be. And you should consider that if you increase this value really much, that you risk overfitting, and if you decrease it too much, you risk that it will underfit the data. And this would be the syntax how you change this parameter. Just when you initiate the model, just call the parameter and assign a value to it that you want. And Facebook suggests to pick any kind of point in the range from 0.001 and 0.5. Next parameter that Facebook suggests to tune, if you want to do some tuning, is seasonality prior scale, which is pretty much the same as change point prior to scale, just referring to the seasonality of the data. So if you increase this value, then you allow the model to be more flexible more flexible regarding the seasonality of the data. And if you decrease the value, then you will take some flexibility of the model away from modeling weekly, daily, and yearly trends. And the same is true for holidays prior to scale. If you increase this value, then you give the model the more flexibility to deal with holidays, which I actually didn't include here, which is also a nice feature which I can talk about in a second. Another tool that Facebook suggests to to adjust, if you want to, you can change seasonality mode from additive to multiplicative and look if it increases the performance of your model. And as I said, holidays, I didn't include holidays here, but Profit has a really nice feature that you can just with one line of code add country-specific holidays to your model. So that would be up here when you fit the model. You could just add holidays, and it has some inbuilt functions for specific countries, for example for the United States, and then it automatically includes the most prominent holiday days in the United States into the forecast, and checks whether this has an effect of the variable that you want to forecast. And also you can include specific holidays that you create yourself. For example, you can create a data frame with specific dates. For example, if you are a retailer, you can include Black Friday and as a holiday, and then your model will include special effects around this time in the forecast. Let me get back. And again, the most impactful parameter to change is this change point prior to scale. So if you decrease it here, you allow for less flexibility for your forecasts, and if you increase it to 0.5, you will allow for more flexible forecasting at the risk of overfitting. That was kind of a high-level overview, because there's so much stuff that you can do with this tool. I would highly suggest, if you're interested, to read the documentation. They have a really nice example there where they're forecasting the Wikipedia page views of Peyton Manning, which is a former professional football player. Really, really cool example. And if you want to dig a bit deeper into the theory behind it, how the profit model works, then I would suggest you to read the paper, which is called Forecasting at Scale, which is written by the two lead developers of Profit about the theory behind it. And that's basically it. Thank you.